All right. So now that you can see that a little easier, so those students in class now have a tool, they can see it on their screen a little easier. This is also recorded. Whatever we do in here, we record. So when you run into problems, and you are going to run into problems, this class is going to make your brain hurt. There is no way around that. This is not a class where you can come in and you can listen to me talk and you magically know everything. This class, you have to try things and to look at things. So the first thing I want to talk about today is your homework assignment. And most of you were really, really close, if not a really, really great effort. So there were a few weird things, and I want to point out a couple of issues with it. So on week 6, at the bottom of week 6, I actually posted a sample and so I want to look at this sample a little bit and go over a couple of the reasons that things are in there and why they're in there. So our start and our stop, nothing unusual there. Now, technically, I should have indented everything to show that everything was in a code block. And I didn't, just to make it a little easier to type out, quite frankly. The reality is that start and stop tell me that everything in there between those two is a piece of code, a code block. And some of you are still not indenting and showing me that code block. And when we get into Python, which we do this week and next week, to start out, Python depends on that blocks. And in fact, it's going to go, nope, I don't even know what you're trying to tell me if you don't use those indents. So here I've just put my declaration. So these are all the variables that I think I need. So I just said, I know I'm going to have a couple of things. I know from the problem, and the problem said, I think it's Watson Elementary or whatever, and there are up to, is it 30 students in a class? Up to 35 students in a class, 30 classrooms. Okay, so we have that. So the possibility for a lot of student data is in there. And so we know that we're going to use a couple of variables in there. And so student ID is one that we were given in the problem that says they're going to input class number. So in other words, what class they're in. Score, because we're going to use that as an input device. Now, there's another one here, because this problem actually says, I don't want to know what the total number of points in a classroom is, because that's not very useful to me. What I want to know is an average. And so we have the idea that we're going to get an average, so we're going to calculate an average. Then I have this size, and size we set at 30, because that's the number of classrooms, right? One I didn't do, and I probably could have used it, was that count of 35. I didn't put that in there, and here's the reason why. Nowhere in that problem it says up to 35, but occasionally maybe they shove 36 students in. How are we going to deal with that? And we would have to go back and recode some of our programs. So I don't have a constant. So in other words, anything we type with the capital letters we say is a constant and not going to change. I also created a couple of arrays of data. And so the first array is one for total points. And total points then has 30 boxes. Now, really this should have been 0, 0, 0, 0. So in other words, all of those boxes were set empty. I didn't do that, and I didn't create a loop to set them equal to 0. But I just want you to know that we really should put zeros in those boxes. We don't know what's in there ahead of time. Some languages do a really great job of cleaning that data out for us, and some don't. So since we don't know what's in there, we should have really put and created a quick loop to put in zeros in every one of those. I also created one called class count. And most of you came up with all different kinds of names for this, but I created an identical array in size to this. And so what I should have done is put in a loop that said So while total points, and I looped through or said while something is less than size and made a 30-position loop. Or I could have done a for I equals 0 to size. And then inside of there put total points I equal to 0. And so that would have looped 30 times and came around and said, put a 0 explicitly in there. So.
You could put that up in the declarations like that?
I can actually, because it doesn't care, at least in this particular code. What I just want to show is that I set that up and set those equal to 0. And so that's all I did here with this was I said, all right, we're going to set it equal to 0. And some languages actually have a really handy feature where we can do that. When I set in, I can set in a single value into every one of those, kind of a house cleaning, cleanup. So I have all of these pieces, so those are in my, what you might want to call my list of whatever I'm doing. So my first piece of actual code, now that I got my indenting all messed up, my first piece of code then is really where it says input student ID, class number, and score. And that's on top of that loop. I haven't entered a loop yet. That's that priming that pump input. So we do that once. And then I write a loop. And this loop, now ignore the score because that looks weird because I made this big enough to see on your screen. So this loop says while not end of file. In other words, we created something where if they typed in 999, it would exit out. Or in a lot of cases, nobody's typing this. We're actually pulling this from a database or a file or something else. That input doesn't mean somebody has to physically type it in. We're getting data somehow. And so while we still have data to put in, this entire loop here runs continually, over and over and over again. And I added a couple of pieces just as an error check. And so one of them I did here is I put this in an if statement. So instead of just taking that data in and not checking it, I did a little bit of cleanup on it. And I said if class number is greater than or equal to 1 and class num is less than size. So in other words, if they put in a classroom number between 1 and 30, we're going to consider that a valid input. And if that's true, then we say total points is at class number minus 1. Because remember, we have to take 1 off because the person wants to count by 1s. We know we're counting by 0s to start with, right? Equals total points for this bucket plus whatever score they have. And so if I make that smaller, the indenting goes back to what it should, and that score jumps over at some point. But it's a little easier to see when we make it bigger. So that's no different. We're saying, all right, points are equal to points plus 1 for each individual classroom. But I also did a way to keep track, a counter for how many students are in each classroom. And so I used class count, and I used the same variable or the same index. And so we've made a set of parallel arrays that we can keep track of a count. So equals class plus 1. So every time this is valid for a particular class, we add 1 to their value. The else then says if this isn't true, so if they enter a classroom number that isn't true, so in other words, they try to enter classroom 37. We don't have a classroom 37. it's going to just error out and come down here to this else and say, output's invalid, try again, basically. And this end if, so our if statement ends here. So the code continues and comes down and it re-inputs their student ID, class number, and score. So they can put in the wrong number 100 times in a row, and it's just going to keep asking for an input. And it's based on this loop here. And so this loop, so here is our entire first loop. And that gets our data. That gets our count. So we're able to utilize that to get some valuable information. So then I needed to figure out a way to output that data. And so I had one thought in my head as we're going through here, and that is we have a couple of problems that could pop up. So the first thing I did was I reset class number back to 0, and that's one that I saw people didn't do when they output, is we didn't reset those counters. So if you see a comment about you need to reset your counter, that's what we're looking at. And then I put this inside another loop. And I said, so while class num is less than size. Okay, so we're going to count back up again. You lost your screen? Did everybody lose it or just you? Yeah, it's on a windowed piece, so if you can actually drag it away and make it go away accidentally. All right, so I put this in a while loop. So I said while class num is less than size. So in other words, we're going to count from 0 up to 29 because at 30, 30 is no longer less than 30. So we have 30 buckets we're going to fill again. But I did one extra piece in here. Because what happens if we divide by 0? Can we divide by 0? No. Your computer goes, buzz, can't do it. You'll get some kind of an error if you do it in Excel. So what I said was, if class count of each class, I checked first, so as we count through those, is equal to 0. So in other words, there weren't any students. Then I just set average equal to 0. Otherwise, average is equal to total points of a particular class divided by the class count, and then I ended my if statement. I then output, and I had to add that 1 in there so it doesn't say class 0 and they're expecting it to say class 1, average. And then the very last and one of the important steps that we often forget is I have to have something to change that sentinel value. What controls this loop is class num. If I did not increase this down here, I would be stuck at classroom 0 and I would just print that out until I turned the computer off. So I then end my loop. So that is my entire second loop. Now, are there a lot of other things I could do to make that even prettier? Yeah. One thing I did not do, I did not check to see if the scores were valid. So I could actually add an additional check in here for the scores. So I could actually say, and, what do we call it? Score equal to or greater than 0, and score less than or equal to 100. And I can put in 4 different statements in there. All of those have to be true for that to work. So then I'm actually checking, does that score fit? Because we said in there the scores could be from 0 to 100, I believe, right? Or we could even say, we know some teachers are going to put in extra credit. Now, what I would do if I'm going to do that is I would generally come up and create a constant and do it that way. But we can actually have multiple pieces up there. So every one of those has to be true when you input data, or it's just going to come down here and say, nope, that was invalid, and loop back up and run that again. So when we start looking at validating data, you think people are never going to put in the wrong thing, and you would be amazed. They will put in an O for a 0, they will type in letters, and so this way we would actually check it a little more. And so we could do those kinds of things if you wanted to. We could do all kinds of things on our output to make it really nice. You could say, oh, if your average is above 90, you get a congratulations, or you could do all kinds of things. This meets the requirements, though, and has those outputs and shouldn't break. And that's one of the things we're looking for is how do we create code that doesn't break? So this one's up there. I encourage you to look at those things. When I post them in there, and when you guys start posting your own work, it's a really great resource to go look and see how did somebody else solve this problem? What did they do differently than I did? And so one of the things I saw in here with several students is you really had part of this right, and then you ended like the count you put outside of this loop. And it's never going to increment. And so little things like that are what got most people. So when you do something like this, work it through. Pretend that you are putting in numbers or data and see what happens. Does it work as you anticipated? So in here, if I put in student ID, and really the student ID, does it even ever come into play? Do we ever use it again? No, in this particular case, it just kind of dies. But the class num and the score do. So if I put in the values of John is my student ID, maybe they're using all numbers, and I put a student ID of 1, 2, 3, and a class number of 7 or 5, whatever it is, fingers and hands are typing, and a score of 90. What happens to that data? So I don't check on this, but I do check on this class number and the score. So is class number greater than 1? Yeah. Is class number less than 30? So it passes that. Is my score greater than 0? Yep. And less than 110? All right. So then I'm going to add that up. So total points of this particular one. So that would be the total points for not classroom 7, but 6. Right? Because we have to go backwards 1. Is equal to the total points, whatever was in there before, plus this score. So if nobody else was in there, it would be equal to 90 points right now. So sometimes it's even handy to break out the old Excel spreadsheet. Because I can create those parallel arrays. So I could say, here's my array for total points. Here's my array for count. And so this is box 0. This is box 1, 2, 3, 4, 5, 6, which is where we're at. So total now would be 90, and my count would be 1. Well, now if I run another student through there, and it just happens to be that this particular guy is, and Mary has a number of 223. We happen to be in there, and she's a smart cookie. Now, grab the wrong one. It would be helpful if I grab the Excel spreadsheet. So now I have 189 in there, and my count is 2. And those add up in each one of those boxes as I go through there. So how we lay out this structure then, we could actually build one in Python very, very similar to that. And we could actually get you to type in data Or you could get data out of a file at some point, and you could do that. So, what I did not count off, if you did not have any error checking or anything, I did not count off on this particular assignment. It's good to have, and becomes easier when we can start doing things in modules and blocks. So when we have input statements, most of the time we're actually going to do those in kind of a block, and we'll show you what that looks like. So this week you have a quiz. There is an assignment, but one of the things I put in is some sample solutions for a couple of other problems. So chapter 5, number 5 is in there, I believe it is. So there's some other ones in there that you can actually look at. Let me close some of these out. So I have another one in there. Occasionally, these weird question symbols are because it didn't understand the symbol in there, but hopefully you can understand what's in there. So we're going to give you some samples. Those are really what you need to look at and try to see, hey, can I do something similar? How did they achieve that same kind of a solution? So this week, chapter 6, so I have last week's solution. We're going to introduce something called a method. There's a lot of other names for this. So we may call it a subroutine, a procedure, a function, a method. So some of you, a couple weeks ago, had an issue where we took code out of a Chegg, or it was in Course Hero, wherever it was, and it actually had some of these items in there. It had modules or subroutines. And that's one of the reasons when I looked at it, I said, well, we haven't covered this. I don't think you understand what we're doing yet. After today, you hopefully will, or have a beginning on that idea. So we want to be able to create something so that we can call it from another program or from within itself. So we want to create modules, whether they set in another file, whether we set them inside of our own code, so that we can do things over and over and over again. What we find, if we look at a lot of our programs, so that one, so if I look at a program like this, there are things that we do repeatedly. So in this case, I'm inputting this particular item over and over and over again. And in most cases, it's not just going to pop up on the screen with boxes. It's going to actually have a lot of content to it. It's going to say things like, you're going to have like a print statement or an output, and you're going to say, please input a student ID, class, number, bless you, score, and you're going to be very verbose in what you're going to put in there. Because we know that we can never underestimate the power of human stupidity. Whatever you think they won't do, people are going to do. And so you're going to put in a lot of instructions. So you're going to have a lot of content in there. And I want to repeat that a couple of times. So I can do that. I can copy and paste it in there. But wouldn't it be handy if I had a module that said all I had to do was call it, and I said I want to call something and say input data. And so instead of having to have all those instructions and everything, and because I use it in multiple places down here, I have the same thing in 2 places. And everywhere in the program I use it, I could use that same function. And maybe it's even as simple as, even easier one, how many times do you get asked a yes or no question when you're inside a program? If you're playing Fortnite, how many times do you get asked a similar style of question? And so we reuse those things over and over and over again. So it doesn't matter how many times we use it. We can reuse it over and over and over again. And so in our short program, we can just copy and paste, and that works pretty well. As we get to a bigger program or one that executes multiple things, this really becomes a great way we can do it. So we call it this idea of modularity, modularizing programs. The other thing that's really handy is it gives us something called abstraction. In other words, I don't have to worry about the details about that input statement. I created that once. I don't have to make sure that all the pieces are in there each time. I can then just call and say, hey, I need to get input of student data. So think about MyPSC. How many times do you guys have to enter in data into MyPSC? Yeah, I'm not going to write a program where I have to go out and put in all of that every time. I'm going to call a function and I'm going to say, hey, do this for me. And so I'm going to have that ahead of time. So that idea of abstraction. So we don't have to pay attention to the details. We're just really doing that high-level thinking, and that gives us an advantage. It also gives us an ability to have multiple people working on the same program. We create that structure that's inside that input, and I can have 3 or 4 people all working on that code that modifies that data, and they all get the same piece of data. So, modules give us a really powerful tool. Cuts our program down. Very complicated things, we can even put it where it's in another file, where it goes out and runs a file that's stored on our computer. It doesn't have to be contained in our code. It gets rid of that repetition, so we're not looking at the same code over and over and over again. And the other problem, when we do something over and over and over again, we tend to make sloppy mistakes with it. And so it hopefully eliminates that idea of sloppy mistakes. It allows us to put it together with a lot of people. And if you have something that's really, really great, you may come up with a great module to do something. Maybe find a card. So you're going to create a card playing game of some sort. I can create a function that goes out and does something, and I can reuse it over and over again. The other part of that is once I've established that it works really, really well, I think it's reliable, I can put it into other programs or other features of my program. So, in your... Did I open that one? I did not. Okay. Get that out of the way. So, in your book, on week 6, I'm going to make this a little bigger, and we're going to look at what these look like. So I'm going to put this back into Word just so we can see it easier. Alright, so hopefully that's a little bigger and we can see it. So this program, the program itself is only this. That's all the program is. It says, I'm going to have a declarations and I'm going to ask for a username. So in this program, we only have really one variable. And we actually assign name is equal to ask user for name parentheses. Those parentheses are kind of our key that we're asking for something different. Every time we run a function, we use those. All right, well, that seems weird. Have I seen that somewhere before? So I want to put a formula in that tells me what today's date is. What's the formula for that? How do I do a formula in Excel? Okay, so we always start with equals. Oh, wait a minute. Up here we said equals because it's assigning something. So that's the same thing. You're assigning the output of a function to this cell. Assigning the output of this function to a variable. So there is a function that will give you today's date and time, and it's called now. But what do I have to do to tell Excel that it's a function? So this comes right out of our programming language. Even though we're not putting any data in there, I have to open and close that parenthesis, and it tells me that it's going to be a function. And it says it's 2/12/2019 at 10:31. So that's a function inside of Excel. And that assignment operator works the same way. That equals says I'm going to shove the value of this into that cell, which is right here. So here I'm saying I'm going to run a function called ask user for name, and I'm going to take the output of that and shove it into name. I can then output name, all right, so let's look at that. How does that work in this function? So in this particular case, this function or this module says, it starts with, it says, I'm going to declare what kind of a function it is. And it says, I'm going to create a string. It's ask user for name. Well, that makes sense. A string. We're gonna output something. Inside of it, we're going to have a declaration that says string name. And the output says, please type your name, input user's name, and then a return. And so almost always our functions have a return. And so everything inside this block runs when we call that function. So when we use some kind of a method to call that function, so here we say name equals ask user for name, it's going to run this function. Okay. So it says, all right, name, please type your name, you put in your name, it's going to shove it back up into this function and assign it to the value name. Now, what's wrong with this particular program? Do you see anything wrong with that one? Is there anything weird that jumps out at you? So here we have a variable user's name, and here it says output your name is user's name. Does that seem to be okay? So here's the problem that you're going to run into. These modules also isolate variables, and that's good. So if this module were asking for your social security number, you don't want every piece of that program to be able to access it, right? So there's a little bit of issue with this, because here it says your name is, do we ever use this variable? This really should be, you're outputting this. So here we get the variable, and we input a value. It comes back and shoves it into here and out to this variable name. So in most programming language, if I try to use user's name, this variable here, directly, it's going to say I can't find that variable, and it's going to error out. But I can get around that because I assigned it then to this temporary variable here called name. So I created a module. All it does is says, please type your name. But we could put all kinds of other content in there. You could put in there, indents aren't going to quite match. If name is equal to Barry, and you could do all kinds of things to somebody's name. You could change it up, capitalize it, anything you wanted to do in here, that's all going to run. Everything included in this piece is going to run when I call that variable. And so we're going to start breaking our programs pretty quickly in Python into those little modules. Because once I have this module down, I don't need to reinvent it. If I have a game or a program that I'm going to ask for a player's name, hey, I've already got this module written. This is when I say, hey, it's great to copy and paste because you've already written a piece to do step A. You know that module works. You know that it gets the result you want. You know what those variables are. Now you can copy and paste that in there. And you can utilize that again. The other piece, though, I really like is comments. Comments are free. So make sure you use comments when you start to do this. It will help you when you try to figure out what's going wrong in my code. So I can certainly put it in this way. This module returns a user name. And so we could do that. And so whatever content we have in here, the more things I put in there to tell me what it's doing, not only does it help me, but if I'm writing modular code, everybody else who gets to use that code can see what's going on. And maybe they do have to make a tiny tweak. Note those things. So that is the idea of a module. So in this case, does it really make the program any shorter? No, not in this case. But if I ask this just one more time, then think about the savings I would have in that. And so that's why we want to show you some of those examples of what that looks like. So a method, which is what you just saw. So sometimes we call them methods, sometimes we call them subroutines. We almost always give it a name. It's almost always got open and closed parentheses right beside it. Now we're going to modify that a little bit in the future when we get into our coding, but that module has a couple of things. It's got a header. So we'll come back here and we have a header where it declares what kind of module it is, and here it says it's got its name. It's got a body, so what's happening? All right, so here's what's going to happen inside that module. And then it's got a return statement. And that return statement says, when does it go back to that same line? So it's going to go back to that same spot in that program that it ended. So here's an example of one of those we could do. If we have similar things, so note here we have a code segment that goes Hij, and we don't know what all it does, and here we have Hij. I could create a module to eliminate my duplication of that. So I don't have that duplication. So make sure you read this chapter, look at it. We'll work on some problems very similar to the homework on Thursday. For those of you that are on campus, what is tomorrow? Business contest. All of you are signed up, I hope. No? You should be. You get a dress up. There will be a lot of high school students on campus tomorrow. So make sure you're aware of that. If you're going to go to the cafeteria, good luck eating. It gets a little crazy. I would advise going to the Bob because it's probably a little less crazy tomorrow during the day. So if you have a business class, most of those are canceled, just as a reminder. Most of you, though, will be working at that contest, I hope. All right. Let's get out of here. Read chapter 6. Work your way through some of this. This is really our last content out of our book. And then we're going to start getting more hands-on. So we're also going to run through really quickly how to install Python again so you can all have that done.